Okay, chapter 2.5 is solving matrix equations. This will be our last video of the chapter. I might have said that last video, but I decided to make that video shorter, so you're welcome. Stop complaining. A couple things to understand, and we talked about this in the last video. This right here is the inverse of matrix A. So here's matrix A, and here's the inverse of A. If you do A inverse times A, you end up with the identity matrix. Remember, the identity is where the ones in the diagonal with the zeros everywhere else. And the ones and zeros can be anywhere, it doesn't really matter. I'm sorry, the size can be anything, that doesn't matter. The ones have to be on the diagonal, that's always a square matrix, but that's your identity. You can also do A times A inverse. You can flip the order. A times A inverse or A inverse times A both get you the identity. That's important because that's not always true. A times B does not always equal B times A when you're dealing with matrices. It does a lot of other things, but not with matrices. And let's just quickly refresh how to do matrix multiplication. We're going to do this row onto this column. So that's 5 times 1 is 5, 1 times 2 is 2, negative 2 times 3 is negative 6, and I add those up and I get 1. Then I'll do this row into this column, that's 3 plus 6 plus 3, which is 9. And I'll do this row into this column, and that's 2, minus 2 is 0, plus 0 is 0. So that's 190. This is the new matrix. Because remember, this is a 3 by 3, this is a 3 by 1. When you multiply those, the outer numbers get you a 3 by 1. Did I do all that right?
5 plus 2 minus 6 is definitely 1. 3 plus 6 is... yeah, this one feels off. 3, 6, and 3 should be 12, not 9. I did this just a little bit ago and I got different numbers, so I'm glad I checked this one. And then 2 minus 2 is 0 plus 0, 0, that one's good. Okay.
Quick refresher on those things. So, here is where this matrix stuff starts to get really useful. This is a 3 by 3 system of equations. We haven't solved these by hand in class. We can. I used to teach how to solve these by hand. And then I've kind of stopped bothering. Because we can do it so effectively and efficiently and correctly by matrix. So here's what I'm going to do. I'm going to take all of this stuff here. But I'm only going to take the coefficients, just the numbers. And like my good friend Beyonce often says, we're going to throw it all in a box to the left. And I have the coefficients 3, 2, 3, negative 4, 3, negative 2, 3, negative 4, negative 2. There are the coefficients of those variables. And I said a box to the left, you're like thinking that's to the right, but there's going to be more stuff that comes after it. Here we'll have another matrix. And this matrix is a 3 by 1. It's just the variables x, y, and z. And notice what happens when I multiply these. If I multiply these variables, or these matrices together, I'll do this row onto this column, which becomes 3x plus 2y plus 3z, which is that. And if I do this row onto this column, it becomes negative 4x plus 3y minus 2z. And if I do this row onto this column, you'll never guess what I get. 3x minus 4y minus 2z. This here perfectly matches this half of the system. So these two matrices multiply to give me the left half of that system that I had. Well, then now all I have to do is set it equal to a new matrix. 15, 26, negative 2. And I have taken the system of equations that were written as linear equations, and now it's written as a massive matrix equation. And this matrix equation I can solve with matrices, believe it or not. So we're going to call this matrix A, because why not? We'll call this matrix X, because it's our variable to try to find the X matrix. And this one over here, I usually call it the result matrix. A is the coefficient matrix, B is the variable matrix. So I'm sorry, A is the coefficient matrix, X is the variable matrix. This matrix B I call the result matrix. There might be a better term for it, I don't know, that's what I use. And we now know that A times X equals B. But what that means is, this right here is the same as this right here. I'm going to clean all this up now so you can barely read it. But those two things are not the same. I can solve this matrix equation. And like we're going to do in this class very, very often, I'm going to compare it to a simpler problem. And by simpler, I mean something we've seen before. Suppose that 3 times 4 equals 12. No, not even 3 times 4. 3 times x equals 12. Well, we know that x is 4, but to solve this equation, we would probably divide both sides by 3. But the other option, because with matrices we can't divide, there's no division of matrices, the other option, instead of dividing both sides by 3, I probably just should have hit undo there, instead of dividing both sides by 3, we can multiply both sides by the reciprocal, which we call the multiplicative inverse. Multiply both sides by the inverse of 3, which is a third, and that gives us x equals 4. Well, here I want to solve for this x. And I can't just say x is 3, because x actually represents 3 different variables. But I can multiply both sides by the inverse of a. Just like how over here I multiply both sides by the inverse of 3. And now these two things combine to give me the identity. I know the identity times x is just x, so we get x equals a inverse times b. A inverse times b. This is a beautiful thing, because now I've solved for variable x. And I can just jump over to my calculator, type in matrix A, type in matrix B, and do a little bit of calculator arithmetic. So we're going to go to second x to the negative 1, which is right here. This button right here. And I'm going to edit matrix A, which is a 3 by 3, and I have to overwrite these old ones from a previous matrix. So here I'm going to put 3, 2, 3, negative 4, 3, negative 2. Sorry for that sigh. 3, negative 4, negative 2. Good, there's matrix A. Now I'll quit. Second mode is quit. And I'll go back to second x to negative 1 and edit matrix B. It's a 3 by 1. And it goes 15, 26, negative 2. I'll quit out of this. Here's the beauty. I can do second x to negative 1 and just not press enter. Just grab matrix A. Here's matrix A. Do that inverse. Find the inverse of A, which was this button right here. Delete all those inverses now. A inverse times B. Ugh. X is 8, y is 12, z is negative 11. We just solved a 3 by 3 system with our calculator. And that didn't feel much faster because I was talking through everything with some pretty good detail. Now, if we can just kind of remember this little ditty right here, that x equals a inverse times b, we can solve any system of equations, 2 by 2, 3 by 3, 10 by 10, whatever we want. Here's a 4 by 4 system. It has 4 variables, w, x, y, z, and it has 4 equations. So we're going to make a matrix out of this. Now I just want a times x equals b. And you can think of it this way if you want, but eventually we're going to work our way down to just x equals a inverse times b. So if you can just find a and b and go for it, you're all set. Anyways, my A matrix will contain these coefficients. So A is going to equal 2, negative 3, 4, 5. Sure can make these numbers nice for you. There's no W on this one. Notice that. This doesn't have a W. So this is going to go 0, negative 4, 15, negative 1. This one doesn't have an X. So 15, 0, negative 4, negative 3. And this one has one of each. 1 W, 1 X, 1 Y, 1 Z. There's matrix A. Here's matrix B. 32, 28.6, 18.8, 1.4. Now this might not work out terribly clean. I'm not actually sure. I think it's going to come out okay, but we'll see. It doesn't actually matter though. If the answer isn't clean, you can still just check it and see if it's correct. just because it's not clean doesn't mean it's not correct. And that's one of the nice things about matrices, is like doing this by hand, if it's not going to be a clean thing, is a bit of a pain. You're going to have decimals and fractions and all the numbers get messy. But here we can just plug in the stuff and see what happens. 2, negative 3, 4, 5. 0, negative 4, 15, negative 1, 15, 0, 4, negative 3. So that's negative 4, negative 3. One little mistake, it's all off. But that's how it is oftentimes with most things, not just mathematical. Drive your car outside the line for just a second, you're in real trouble sometimes. There's matrix A. Instead of matrix B. 32, 28.6, 18.8, 1.4. Good. A inverse times B. That's all I need, A inverse times B. I can just type that in and there I go. Ha! My answers are x equals 2. So matrix X is 2, negative 4, 1, 2.4. That gives me WXYZ. Will you examine your zipper? But without that extra Y for you. Will examine your zipper. Talk to Will. Cool. Matrix equations, solving, awesome. Sometimes they're unsolvable. This is a 2 by 2. You'll notice that this is times 2 here, and this is times 2 here, but this is not times 2 here. So this will be a no solution. So we can tell right away this system has no solutions. But if you do it in your calculator, because maybe the system's really big and you can't see that, or maybe you don't look for that sort of thing, but if you want to do it in your calculator first, I'll just start editing matrix C and D now. C is a 2 by 2, and I'll type in 3, 2, 6, 4. And then D is a 2 by 1, it's 10 and 10. Now if I do A inverse times B, quit out of here, excuse me, and C inverse times D, it says singular matrix. That means this cannot be solved. If something is infinite solutions, or if it's no solutions, you can't solve it by matrix. Now, of course, a no solution you couldn't solve anyways. An infinite you could, and so you have to maybe play with it somehow. And another extra credit problem that I will leave is why is it that these come out to a singular matrix? And when it says singular, what that really means is you can't find an inverse. Nah, that's not exactly what it means, but that's what it ultimately dictates. You can't find an inverse of this equation, of this matrix here, which we call matrix C in this equation. Why? My question for extra credit online, if you're taking my class, is why will that always happen? Shouldn't be that hard to find if you want to play with it. Okay, we, in our very first slide of this whole chapter, talked about your diet. Eating some Cheerios, some macaroni and cheese, and some trail mix. And you were trying to get this much protein, this much carbs, and this much fat. And I gave us these equations. And that was our system, where X stood for this, and Y stood for this, and Z stood for this. And I said our goal for this chapter is going to be to be able to solve a problem like this. And now we can very easily and very quickly solve a problem like this. And you're probably getting tired of seeing me typing these things into the calculator. And I thought about having all these things pre-typed so that you wouldn't have to watch me do it all. But then people complain that I do things too fast. And they don't know how to do the buttons, and they're like, wait, what did you do? So yeah, I'm gonna make the people that complain about calculator stuff happy as opposed to people that complain about seeing me do this too much happy. 429.5. Okay, there's matrix A. I'm going to edit matrix B. 3 by 1. I'm going to go 58, 236, and 157. Now, A inverse times B. Need to clear this maybe? No, this will work. Gives me this. And it's like, well, shoot, negative 18, 7.4, and 3. If I am trying to meet my dietary needs based on these three things, bowls of Planet Cheerios, boxes of Kraft mac and cheese, and servings of trail mix, I can't. I have to like take out, eat negative Planet Cheerios to make up for all of the extra boxes of Kraft macaroni and cheese I want to make. So this came out to a negative number, which in this sense, in this context doesn't make any sense because the combinations I'm trying to get a balanced diet based on just these three things isn't possible. Because they want me to eat a ton of mac and cheese and a decent amount of trail mix and just completely cut out Cheerios. So, you know, maybe I adjust what I eat or maybe I adjust what my goals are. But if nothing else, I can now at least solve equations like this really, really quickly and easily. So let's recap this now. Any system of equations can be written in matrix form, which is matrix A times matrix X equals B, where A is the coefficients, X is the variables, and B I call the results. You might call it the answers, but it's not, because technically X is the answers, and not. Let's just move on. If the system is solvable, you can find A inverse. If it's not solvable, when you try and find A inverse, the calculator will tell you singular matrix. With matrix algebra, we can solve for X by multiplying both sides of the equation by A inverse on the left. So we would do A inverse times B. This is really, really wonderful. I hope you see that. If you don't, take my word for it, and then I'll see you again next time. Hey, you did it. You watched a whole math video, or you at least skipped to the end here. Either way, thanks for watching. I hope it was helpful. If it was helpful, maybe share it with a friend in your class who could also use it. You can subscribe to follow more videos. You'll see links popping up on the corners to watch previous and past and good videos. You can always leave a question down below or just add a comment. And I hope you have a wonderful day. Thanks for watching.